Hello, my name is Nitin. SPIAC asked us to test the latest software release of DASY8 Module SAR, which is version 16.2. According to the release notes, version 16.2 adds several new features and improvements. The most important one is the capability to evaluate multi-transmission specific absorption rate in specific phantoms. For example, smartwatches when tested on the wrist phantom, or virtual reality goggles tested with the face down phantom. Version 16.2 includes a lot of small but very useful new features. Sound notifications are now available after measurement completion, and the base station simulator automation has been greatly improved. SPIAC also claimed that the smart zoom scan and the communication system verification with Maya have been greatly improved. I can confirm that I have tested over 150 configurations with different mobile devices without the need to repeat any scan. On the post-processing side, 1D plots can now be easily extracted for more advanced field analysis. However, today I will first test this patch antenna that SPIAC just released for system check for the Wi-Fi 6C bands. I will evaluate this patch antenna at 6.5 GHz with the latest beta version 3.2 of DASY8 millimeter wave module, and then with the APD feature of module SAR version 6.2. Afterwards, I will also check the multi-TX evaluation capability of the new software on specific phantoms. This patch antenna is very simple and can be well characterized by computational methods to derive target values for the incident power density and the absorbed power density. The target values have been determined by SPIAC and independently confirmed by a second academic partner. The results are summarized in this report. To begin, I place the patch antenna on the millimeter wave phantom and connect an RF cable. The antenna is fed with the standard signal generator and bidirectional coupler setup. The forward power is measured or monitored by the power sensor connected to the coupled port. The project setup consists of the FA and 5G scans with default values, while the post-processing algorithm is set to equivalent source reconstruction. I start the scan and accelerate the video. The scan is now finished. The measured values of peak spatial power density are 204 and 127 watt per meter square for 1 centimeter square and 4 centimeter square averaging area respectively. These values are only 0.2 dB different from the target values defined in the report. Next, I place the antenna beneath the flat section of the SAM phantom with a 5 mm foam spacer. Remove the millimeter wave phantom from the setup and change the probe from millimeter wave to SAR. The project setup in DASY8 version 16.2, like for all other scans, consists of a fast scan and area and zoom scans. I start the measurements and accelerate the video. So the scan is now finished. The APD value is 78.9 watt per meter square and 43.3 watt per meter square, corresponding to 1 and 4 centimeter square averaging area. This is only 0.24 dB off from the simulation values from the report. This demonstrates that SPIAC has further improved the accuracy and reliability of compliance testing in the important Wi-Fi 6E band. I think this patch antenna is extremely useful and adds confidence in the setup. It would be beneficial if this antenna could be added to the IEC or IEEE standards as a system check source. Now, let's see what are the other new features of DASY8 Module SAR version 16.2. The new powerful post processor allows me to not only look at the SAR distribution slices but also to extract and plot SAR along points, lines, or areas. Markers can be defined on the plots and quickly compared. The plot values can also be exported to Excel for further processing. The new post processor also allows me to look at SAR decay plots along different axes, and this is very useful to understand the SAR characteristics of devices. However, this is not all. The new release also allows evaluation of multi-transmit SAR measurements on the device under test in application-specific phantoms. I will now test this new combiner using my earlier measurements for actual devices on the wrist phantom. Here in this project file, I have two scans measured on the wrist phantom for a smartwatch. This device had an LTE transmitter that works simultaneously with the Bluetooth connection. The individual 10 gram SAR values for the two test cases are 0.795 watt per kg and 0.211 watt per kg. I select the volume scan for the two measurement cases and click Combine, which creates the combined test case with the combined 10 gram SAR value of 0.995 watt per kg. The combined SAR plot is post-processed by evaluating the point SAR for each individual distribution on a fine grid and then adding the SAR values to produce the overall plot. Multi-TX SAR evaluation can be similarly evaluated for all the other special phantoms such as the headstand, face down, SAM chin and ankle phantoms. The new DASY8 module SAR V16.2 offers small but important new improvements. It makes SAR and APD testing up to 10 GHz easier and even more accurate. I particularly liked this new patch antenna, which I will definitely use for system verification before testing compliance of any Wi-Fi 6E devices in the future. Thanks for watching this video.